All right, so welcome to the second video lesson for Unit 8.5, which is all about stoichiometry. Today's lesson is about what's called gram-to-gram stoichiometry. And let's just take a moment to quickly review what mole-to-mole stoichiometry was. You're given a balanced equation, and you are being given a quantity of one of these substances. In this case, we are being given 42 moles of H2, right? So we have 42 moles given to us, and we are being asked to figure out how many moles of N2 are we going to need to react with those 42 moles. Well, as you recall, those coefficients in front of those substances in the balanced equation, that's a mole ratio, and effectively it's a recipe, right? So the way we would, you could proportionally figure it out, but we're going to stick with our dimensional analysis because that's going to be important as we build upon this. So mole-to-mole stoichiometry, we began with the quantity given, so 42.0 moles of H2. We set up a bracket, we canceled the moles of H2 in the denominator, and we converted to moles of N2 in the numerator. The numbers here in this mole-to-mole conversion fraction is the coefficients from the balanced equation, so 1 mole of N2 and 3 moles of H2. So moles of H2 are going to cancel with moles of H2. The unit that does not cancel is moles of N2, so that is our final unit. And the math becomes 42 divided by 3, and we get 14. So 14, I guess to maintain sig figs, we'd have 14.0 moles of N2. And that makes sense, right? So if it's a 1-to-3 ratio, you would need, if we have 42 moles of hydrogen, we're going to need 14 moles of nitrogen because that's a 1-to-3 ratio. So that makes sense. And that's validating. But remember, the balanced equation coefficients are not a mass ratio. And so that's the added layer that we're adding on to this work. So what if you are given grams of one compound and have to find grams of a different compound? Okay. Let me just move this a little closer so we can see what we're doing here. So instead of given moles, find moles, now you're going to be given grams of one compound, and you'll have to find grams of a different compound. So this is conceptually 3 steps. The first thing you're going to have to do is convert grams to moles of the given compound. And then second, you can use the mole ratio like we just did in the previous problem, moles of the given compound to moles of the other compound. And then lastly, we'll take that moles of that new compound and convert it to grams using its molar mass. In the end, gram-to-gram stoichiometry is a 3-step, meaning 3 conversion fractions problem. Whereas mole-to-mole stoichiometry, if I go back to that problem that we just did, mole-to-mole stoichiometry has only 1 conversion fraction. Gram-to-gram stoichiometry is going to have 3 conversion fractions. So let's see what this looks like. If you completely combust 56 grams of ethylene, the question is asking how many grams of oxygen will be used. So the given quantity is the 56 grams, and what we are trying to solve for is grams of oxygen. So like all of these problems, we will always start with the given quantity. And I'm going to start this problem all the way to the left side of my paper because I got to try to fit in 3 conversion fractions. So 56.0 grams. I'm going to give the quantity, the unit, and the identity. So 56.0 grams of C2H4. And I am going to set up my dimensional analysis where the first thing I want to do is cancel the grams of C2H4. And in this first step, we are going to convert, I'm going to bring these steps up here. We're going to convert grams to moles of the given compound. So at this point, the given compound is C2H4. I'm going to convert grams to moles of that same substance. So this right here is the molar mass of the given compound, in this case C2H4. Is the molar mass of the given substance, which is C2H4. So molar mass is always 1 mole is equal to whatever this adds up to on the periodic table. So I have to do a little side work right here. Okay, so a little side work. I'm trying to fit it all in here. 2 carbons, each at 12.0. Right, each at 12.0. And I've got 2 hydrogens, each at 1.01. So that's going to be 24 plus, nope, 4 hydrogens at 1.01. So that's going to be 4.04. So adding that up, I'm going to get 28.404. Okay. And if I am rounding to the nearest, if I'm doing my sig figs properly, this really works out to 28.4, I believe. 24 plus, yeah. Let's see. 4.04. Okay, so that's just, no, okay, I added up wrong. That's 28.04. This is the problem when you do the math in your head. So this is 28.04. All right. If I stop here, all I have done is I have converted grams of C2H4 into moles of C2H4. Okay. I've only stayed within converting grams of this substance into moles of this substance. But what I am trying to do is figure out the mass of oxygen that it's going to produce. So, all right, I converted grams to moles of C2H4. Let's see what we can do with that. We're in moles of C2H4. I want to cancel that, so I'm going to put moles of C2H4 in the denominator. I know from the balanced equation that 1 mole of C2H4 will react with 3 moles of O2. So I'm going to now use this mole ratio, moles of C2H4 in the bottom, moles of O2 in the numerator. I'm going to use my coefficients. 3 moles of O2 is needed to react with 1 mole of C2H4. All right, so that's like the mole-to-mole stoichiometry we just did. If I stop here, moles of C2H4 will cancel with moles of C2H4. And that leaves me with moles of O2. But we're trying to solve for grams of O2. So no big deal. We can just do one more fraction where we will take moles of O2, cancel it out, and go to grams of O2. This is just basically molar mass, right? This is just molar mass of what we're trying to, of what we need to solve for. And in this case, it is O2. So 1 mole of O2, each oxygen 16, so 32.0 grams. Moles of O2 will cancel, leaving us with grams of O2 as our unit. And the math just becomes, we're just going to do this all as a chain calculation. I don't know if I can show you everything I'm doing all at once, trying to get my calculator in here at the same time. Okay. Sorry if this is a little queasy. Get the lighting a little better. Okay. So I am going to start with the given quantity of 56.0 grams. My calculator, 56.0 grams. I am going to divide by 28.04. I'm going to multiply by 3. And I'm going to multiply by 32. Notice I didn't even have to hit equals in any time. I just, if the number's in the denominator, I'm going to divide by it. If the number's in the numerator, I'm going to multiply by it. All right, and what we have here to 3 significant figures is 192. The unit left over is grams of O2. And there you have it. There's your answer. So the 3-step stoichiometry problem, when you're going from grams of one substance to grams of a different substance, the first fraction is you use the molar mass of the given quantity, of the given substance. The second fraction is where you use the coefficients of the balanced equation. And basically, it is a mole ratio. And the last fraction is where you use the molar mass of the substance you are solving for. Okay, so that's the how you do gram to gram stoichiometry. Let's knock out a couple of problems here to kind of cement this. We've got problem number 3 at the top here. How many grams of gold chloride can be made from 100 grams of chlorine gas by this reaction? That sounds interesting. Let's identify the given substance. It's 100 grams of chlorine gas. That's our given. We are being asked to solve for grams of AuCl3. Okay, so we see here we have a mole ratio of 2 moles of gold. You'll need 3 moles of chlorine gas, and that will make 2 moles of gold chloride. So let's start with our given quantity. Again, I'm going to start all the way to the left so I have enough room to do the problem. So 100.0 grams. Chlorine gas has the formula Cl2. I'm going to set this up as a fraction. And immediately I want grams of Cl2 to cancel. Remember, the 3 steps are going to be, you're going to use molar mass as the first conversion fraction. The second one is going to be a mole ratio. And the third one is going to be molar mass, again, of the substance you're solving for. So, molar mass of the original substance is what we're using in this first unit. So 1 mole of Cl2. Cl from the periodic table, rounded to the nearest tenth, is 35.5. So 35.5 times 2 is 71.0. Okay. The second fraction is a mole ratio, and I'm going to use the unit that is in the previous numerator, and that's going to go in my next denominator. And here's the pivot. Here's where you get to convert it to the substance you are solving for. So how many grams of AuCl3 is what I'm going to. I'm going to moles of AuCl3. So this is my mole ratio, and this is where I'm getting these numbers from the balanced equation. So 2 moles of AuCl3 over 3 moles of Cl2. Last fraction. I'm going to take that unit in the numerator of the previous fraction, and that's going to go in the denominator of my new fraction. So moles of AuCl3. But this one's going to be molar mass, so I'm going to grams of AuCl3. 1 mole of AuCl3. This is going to require a little bit of checking around. So I know chlorine is 35.5, but there's 3 of those. I'm going to jot that down. And gold to the nearest tenth is 197.0. So 197.0 plus, so let's see here. We've got 3 times 35.5. That's my chlorines plus my gold of 197. And that is 303.5 grams. All right. So let's take a look at the problem. I've set it all up. Let's make sure our units are canceling. Grams of Cl2 are going to cancel with grams of Cl2. Moles of Cl2 are going to cancel with moles of Cl2. Moles of AuCl3 will cancel with moles of AuCl3, leaving me with my unit of grams of AuCl3. Let's do the math. We're starting with the number 100 as our given quantity. I'm going to move the calculator over here so you can see what else I'm doing. I'm now going to divide by 71. I'm going to multiply by 2, and then I'm going to divide by 3. And then I'm going to multiply by 303.5. When all is said and done, I had 4 significant figures to start with. So I'm going to round this to looks like 285.0 grams of AuCl3 as my final answer. All right, let's try one more together. Let's see what this looks like. Although mixtures of oxygen or hydrogen and oxygen are highly explosive, pure elemental hydrogen gas, there's a typo there, itself burns quietly in air with a pale blue flame, producing water vapor. Calculate the mass in grams of water vapor. Okay, so that's what we're trying to solve for. When 56 grams of pure hydrogen gas burns in the air. So that's our given quantity. We've got a balanced equation here. 2 moles of hydrogen, 1 mole of oxygen, 2 moles of water. We're going to start with that given quantity all the way to the left side of our paper. 56.0 grams of H2. Remember, we've got molar mass as our first conversion fraction. Our second conversion fraction is going to be the mole ratio. And our third conversion fraction is going to be the molar mass of the substance we're solving for. So molar mass of the first substance, grams of H2, so it cancels. 1 mole of H2 up top. Hydrogen is 1.01, but we have 2 of them, so that's 2.02. Okay, our mole ratio. This conversion fraction, look at your previous fraction. Whatever's unit is in the numerator, that's going to be in our denominator. So moles of H2 in our denominator. Now, here's where you might get stuck. What has to go on top? We know the H2 is going to cancel. But your mole ratio, this fraction is where you are converting from moles of the original substance, and you're converting it into moles of the substance you're trying to find. So that's water vapor. So moles of H2 on the bottom, moles of water on the top. The coefficients, find where they are in the balanced equation. It's 2 moles of water, and it's 2 moles of hydrogen. So there we go. All right, our next fraction is going to be molar mass of the substance we're trying to solve for, which is water. And remember, whatever unit was in the previous fraction, that's what's going to go down here in the denominator of the new fraction, so moles of water. And grams of water goes up top. It's the molar mass. So 1 with a mole, 1 mole of H2O, for water is going to be 18.0 grams. And that's, of course, I'm adding that up quickly in my head, but you would get the masses from the periodic table. Let's make sure things cancel. Grams of H2 is going to cancel with grams of H2. Moles of H2 are going to cancel here and here. Moles of water is going to cancel here and here, leaving us with grams of water, which is what we were trying to find. So that always feels super cool. Our final unit is going to be grams of water. And now I just have to use my calculator work. So I'm starting with a quantity of 56. I'm going to divide that by 2.02. I'm going to multiply by 2 and divide by 2. Really won't do anything, but I'm going to do it anyway. So multiply by 2, divide by 2, multiply by 18. And it looks like I had 3 sig figs to start with, so 3 sig figs here looks like 499 grams of water. All right, so that's how you do gram-gram stoichiometry. It's a little bit more involved, and you have to kind of keep track of the details, so that may be what trips you up. Sometimes molar mass calculations can trip you up. These problems require a little bit of patience and certainly an attention to detail. All right, let me know if you have questions when you try the problem set, and I will see you back in the classroom.